Insulating old mass masonry walls always poses a challenge. Existing mass masonry walls can be insulated either from the exterior or from the interior of the assembly, with each strategy heavily depending on the site's restrictions, the project budget, the existing conditions, and the historical value of the building. While it is highly beneficial to insulate and waterproof mass walls from the exterior of the assembly from both a thermal and moisture perspective, this isn't always possible, as the old masonry facades must be preserved to retain their historical integrity and neighborhood character. So, how do we successfully insulate a multi-wythe mass masonry wall from the interior without damaging the building and causing moisture-related issues? Mass masonry walls control rainwater penetration by absorbing and storing water and redistributing it to the drier inner wythes in a process called hygric redistribution. The concept being that the first layer of masonry would stop about 80 to 90% of the water that entered the assembly, only allowing something like 10% to pass through. The second and third layers, or wythes of masonry, would only allow 10% of the 10% of the water to actually migrate through to the interior, and by the time it actually gets there, it doesn't really matter because the water is evenly distributed and no one would really notice. This is how a lot of walls were built in many parts of the world up until wood framing became common. However, when we go to insulate mass masonry walls and add moisture-sensitive interior materials, we significantly change the dynamics of the wall, as the masonry wall will stay wetter and colder for longer and will distribute that moisture to the interior materials, which can support mold growth and rot. Mass masonry walls also tend to have a lot of small cracks and gaps that wick liquid water deeper into the wall through capillary forces. So, if we're to insulate these old mass masonry walls, we need an approach that allows us to reduce the amount of water absorbed by the masonry wall. We need to prevent capillary forces from sucking water inside the framed wall cavity through cracks and gaps. We need to insulate with a material that's moisture resistant but allows for vapor diffusion. And we need to prevent wintertime condensation that could deposit moisture on the interior side of the masonry walls. To reduce surface water absorption on the exterior side of the masonry walls, we're calling out a silane or siloxane penetrating sealer, which is a chemical agent that is absorbed into the pores of the brick and mortar, making the surface hydrophobic or water repellent. Silanes and siloxanes are preferable as a penetrating sealer as they are highly vapor permeable and allow old lime mortars to dry out. While these penetrating sealers significantly reduce surface absorption, they do not fill in cracks and gaps, so liquid water can still wick through those tiny openings and make their way inside. You'll also need to recoat the surface of the masonry in this penetrating sealer every few years in order to retain its water repellency. Next, we are filling and covering any gaps, cracks, or voids on the interior of the masonry wall with a lime cement parge coat or parging. This parge coat prevents water that has been wicked through cracks on the exterior from trickling into the wall cavity and should closely resemble the chemistry of the mortars used for the mass wall. Typically, this is going to be a lime mortar that is highly vapor permeable. We don't want any polymer modified Portland cement pargings, as these have low permeability and they have the potential to damage the old masonry wall if moisture is present. Then we install a fluid applied negative side waterproofing over the parge coat to provide extra redundancy. Some products can be applied directly to the masonry wall, however fluid applied products can't span large cracks and gaps even if they are elastomeric. The parge coat provides support and a uniform surface for the waterproofing. The fluid applied waterproofing must be vapor permeable at around 10 perms to allow moisture to dry out of the wall to the interior. This fluid applied coating can also serve as a capillary break. There are a handful of products on the market that can serve as above grade negative side waterproof coatings for masonry walls. I personally recommend either Tremco's Exo Air 220 product or Proseco's BMC2. Not sponsored by either of these companies, but they make some good products. After the walls have been parged and waterproofed, we are then installing a continuous layer of rigid mineral wool. Here we're using Rock Wool Comfort Board 80. This will serve as a thermal break between the studs and the cold masonry walls. This is not optional when you're using light gauge steel framing, as the conductive steel absolutely requires a thermal break. We can then install the interior framing and fill the cavities with mineral wool bats. Here we're using Rock Wool Comfort Bat. Mineral wool is highly moisture resistant, hydrophobic, and vapor permeable. Now, this taped smart vapor retarder membrane is the key to the success of this assembly. This will be serving as our air barrier as well as our vapor control to prevent wintertime condensation while allowing the wall to dry to the interior. During the cold months of the year, warm, moisture-laden interior air will want to diffuse outwards to the cold side of the wall. If it hits a cold surface, we get interstitial condensation. This smart vapor retarder prevents that, but unlike a standard vapor barrier, the smart vapor retarders allow moisture to dry to the interior when relative humidity within the wall cavity exceeds about 60% and increases in permeability similar to wood the wetter it gets. We staple the smart vapor retarder membrane onto the studs and tape all the joints, and then we install horizontal strapping to provide an airtight service cavity for electrical conduit, wiring, and other services. And then we attach our standard gypsum board to the strapping, reducing the amount of penetrations into the smart vapor retarder membrane. Remember, the smart vapor retarder is serving as our air barrier. We talk a lot about insulating and managing moisture in mass walls, as well as how to address many other old building assemblies in my book, Moisture Management for Residential Remodels. Oftentimes, these older buildings can hide small leaks and moisture issues, as they were constructed out of more durable materials and had an abundance of heat flow drying out the building. This ebook provides the strategies and details necessary to address moisture issues and prevent future moisture problems the right way the first time for a wide range of building conditions. It is available only at asiridesigns.com/shop. The link will be in the description. Now, back to the video. Now, in this wall assembly, we are insulating with closed cell spray foam. We have to be really careful when we insulate with spray foam because it can trap moisture on the inside and it cools down the wall sufficiently in cold climates to potentially cause freeze-thaw damage, in which the water inside the masonry wall will freeze if it's cold enough, leaving behind salt deposits, which causes efflorescence and spalling to occur where the brick falls off due to high osmotic pressures, since the water present in the masonry wants to dilute the salt concentrations. So starting out, we have that same silane siloxane penetrating sealer to reduce the surface absorption of the masonry wall. Again, this only stops surface water from being absorbed into the brick. It doesn't actually stop water from getting through the cracks in the brick and being wicked inside. And of course, we have our mass masonry wall here. Installed between the masonry wall and the closed cell spray foam layer, we have a taped dimple mat. This is really important because it provides a capillary break between the wet masonry walls and the interior framing, as well as a drainage space and an air gap between the foam and the masonry wall, allowing any water to drain out and dry, preventing water accumulation behind the spray foam layer that could result in damage. We also need to apply a primer to the backside of the taped dimple mat to allow the spray foam to adhere to that high-density polyethylene. So after we've applied a primer to the backside of the dimple mat, we can spray about 2 inches of closed cell spray foam. We don't really want to go any higher than that in cold climates because of that freeze-thaw damage that can occur. We want some heat flow through that masonry wall, just so that the masonry wall can actually dry out. Then, optionally, we can insulate the stud cavities with rock wool bats or any other air and vapor permeable insulation. Fiberglass can work well, as well as wood fiber or even cellulose, as long as it's vapor permeable. And then we're able to install our standard gypsum board right over the studs to close out the wall assembly. So that's really the only way to make spray foam work in a mass masonry wall assembly without the risks associated with moisture, freeze-thaw damage, spalling, and efflorescence. For more information on mass masonry, check out the free articles on my website. There we cover a range of topics from waterproofing and sealing old masonry walls properly to addressing embedded wood components and many other building conditions. Links will be in the description below. Good luck with your projects. Cheers.